Okay, so today we're going to work on the Codility problem from Stacks and Queues lesson 7, stone wall. This is the question. You're going to build a stone wall. The wall should be straight and n meters long. So the array that's passed in has n elements, and its thickness should be constant. However, it should have different heights in different places. So it's never, if we look at this diagram, the height of the wall varies at different points. The height of the wall is specified by array h of n positive integers. H of I is the height of the wall from I to I plus 1 meters to the right of its left end. In particular, h of 0 is the height of the wall's left end, and h of n minus 1 is the height of the wall's right end. The wall should be built of cuboid stone blocks. That is, all sides of such blocks are rectangular, so it only has rectangular blocks. Your task is to compute the minimum number of blocks needed to build the wall. Write a function that, given an array h of n positive integers specifying the height of the wall, returns the minimum number of blocks needed to build it. For example, given array h containing n is equal to 9 integers, the function should return 7. The figure shows one possible arrangement of the 7 blocks. Write an efficient algorithm for the following assumptions. N is an integer within the range of 1 to 100,000, and each element of array h is an integer within the range of 1 to 1 billion. Alright, so I actually found it very difficult to understand this problem initially because I wasn't exactly sure what they meant by the different elements in the array. But after Googling a bit, unfortunately, because I couldn't get what they were talking about, I realized that each of the elements, like h of I plus 1, etc., is the leftmost point of the block. And so if we look at this array, which is shown in the diagram, we have the elements 0 to 9, or 8, I mean. We see the first element was 8, so that's the first point. The second element was 8 as well, so we move over 1 meter, and that's the start of the second element. So even though I have a line here, since it doesn't change heights at this point, this is considered h of 0 and h of 1 are points for the same block. Then we go to h of 2, and we see that the height is 5, so it drops in height, and then we have another block. And then we go to h of 3, moving over 1 meter, and the leftmost point of the block is at height 7. Alright, so let's get back to our question. So, what do we know? Let's write down everything we know based on what was passed in. So, notes. So, wall is n meters long. The first and most important part of completing any algorithmic question is to understand the problem. So always ask clarifying questions, because even if it's simple or you feel like you can answer it, you might be answering the wrong question. So it's very important to make sure you're answering the right question. And I personally feel understanding the question is a lot harder than answering it in most cases, because if you know how to answer it, you'll get it relatively quickly. If you don't know, you don't understand the question or trying to figure it out or are confused about it, you'll be running in circles. Alright, so each element in h of I is height of the wall, right? So what are we going to do? How would we approach this? So let's see. So steps. Let's try and break it down or diagram it, because let's work off this diagram we have here. So let's say we're passed in the array. H is equal to an array, and that first element is 8, 8, 5, 7, 9, 8, 7, 4, 8. Alright, so we start off at the first point. So we'll have a pointer, which is I, right? So wall height is equal to 8, blocks is equal to 1, right? We go to second point, wall height is equal to 8, and we're still on the same block. We go here and something happens. Suddenly we have a smaller block, so wall height becomes 5, and then our blocks, we're on the second block, so we can increment block. But if you notice, the height doesn't always correspond to the number of blocks or the height of the block. So we need a parameter. So getting to this point, we're going to need something to keep track of the height of the we're going to have to keep track of the wall height as well as the block size, right? So currently the block size here is 5. Previously the block size was 8, right? And whenever we pop out the block size, it's going to be whenever the wall height is less than the previous wall height, we will most likely have to pop out the wall height, right? Okay, so let's go to the next element, and once again we get bigger. So we ran into an interesting situation here. So our wall height is now 7, and we have blocks stacked on top of each other, right? So our previous wall height of block size was 5, and now we have another block on top of that that is 2 blocks high. So what we can do is keep a stack, block stack, which will tell us the size of the bricks we already have stored. So stacked up at each point in the array. So currently we have a 5 and 2 at this point. And now we go to the next element, which is a 9, and the wall height becomes 7, and it becomes 9. So then we're going to have another block, and the number of blocks we counted are still staying at 2 because we haven't really removed any. And so we have 2 blocks in the stack that are of block 2. So our current block size is 2. Alright. And now we ran into an interesting situation. We are at the next point in the wall, and the wall height is dropped by 1. But our top block previously had a size of 2, right? So what we're going to have to do is pop from the stack our top block, so we'll only have 2 elements, and our blocks will increase to 3, and we're going to have to re-add another block, right, to make it so that our wall height is 8, so our block size will become 1. Alright, So now we go to the next point, which is 7, right? And which is smaller than the previous point, so we're going to pop out another block. So this was also, we also added a block, so it's 5, 2, 1. So okay, so we have a wall height of 7, which is here. So we can actually just pop out our top block, right? We'll increment our blocks to 4. The block size currently is 0 because we didn't create a block here, right? So we are left with a 5 and a 2. All right. Now we get to our 4. Right? And here's another interesting situation. The wall height is now 4. And if we were to pop out the current standing blocks, we'll have to pop out 2 of them, right? Because 4 is less than 7 and is less than and 4 is also less than our bottom block size. So we'll have to pop it out. So we're popping out and being left with an empty array initially. So that way we'll get to 6 blocks. Right? Because we popped out these 2. And we are here. And now we're still at 5 blocks after the pop. We're still at 4 blocks. After the pop, we'd get to 6, and then we'd have to add a block, right? I'm wondering if I'm getting this right. Okay, so we would pop out 2 blocks, and then we'd create a block that's 4, and then the block size would be 4. Right. So we created a block. So since we got rid of 2 blocks, I think this would be a 6. And we added a 4th block. Size. And so our block stack would be now a 4. Right? And then finally we get to the end where our wall once again increases in size. The wall height is 8. And our blocks stay at the same number at 6 because we're not popping anything out. The block size is also 4 because we're stacking it on top of our existing block. And then we would be left with a 4, 8. So then we would have a number of blocks, which would be equal to blocks plus block stack dot length, right? And that would actually equal 8. Wall count is equal to 8. So we made a mistake somewhere in our derivation, and I think it was so wall height starts off at 8 and the number of blocks is 0 here, right? Because we haven't popped anything out. Here it's still 0. Then it's a 1. here the wall height is a 1 and we had a pop. So the wall is a 1. And then we get to 7 because the wall height increases. And we get to 9 because the wall height increases. The wall height is 1. So we still are at 1 block. Still at 1 block. 9. Then here we have a wall height of 2. So there's a pop. There's 1 pop and we re-add it. So that's 2. And then we're still at 2. No, here's another pop because we decreased to 7. So this would become a 3. And then, because we're only incrementing when we remove a block from the stack, right? Let's keep that in mind. So then we go down to 4, in which we had to remove 2 blocks from the stack. So that'll be a pop and a pop. And so then this would actually be a 5. And so we are at wall height of 5 and stay at 5. And this would actually be 7 because we have 2 left in the stack over. So, okay. So that is where we went wrong because we were starting off with 1 block before actually needing to count it. Okay, I hope that made sense. But anyways, let's break it down to steps. Iterate through array of wall height to calculate when wall height increases. We'll have 2 scenarios. We'll have 2 scenarios when the wall height increases and when the wall height decreases. So those are 2 different calculations we'll have to perform. So when the wall height increases, calculate block size B, add block to stack. Alright, that's our first scenario. 3, when wall height decreases, pop blocks from stack until wall height is equal to h of I, or wall height is less than h of I, right? Because we have that scenario in which our block size might not match. So in the case that wall height is less, if wall height less, create a new block and add to stack. And then finally, repeat till end of array. And then finally our last step would be to add block stack size to number of pops, right? And this will be our answer. When popping, increment counter. All right, so that should do it, and that should be how we can actually approach it, solving our problem. So let's define our variables that we'll need to keep track of. We're going to have our first variable, wall height, which starts off at 0. We're going to have our second variable, block size, which we'll say starts off at 0. We're going to have our third variable, block stack, and this is going to keep track of our the blocks in that stack up for that part of the wall at different points in time. And then we're going to have our fourth variable, brick counter, and this is going to keep track of all the bricks that we have counted. All right, so now let's iterate through our passed in loop. While I is less than h dot length, I plus plus. Okay, so we have two conditions. If h of I is greater than wall height, right? And if h of I is less than wall height. Those are our two conditions, because we don't care of when h of I is automatically equal to wall height. And the reason for this is because that's the same block, so we won't be incrementing anything. All right, so what do we do when h of I is greater than wall height? We calculate the brick size. I called it block size, but it should be brick size. We don't have blocks, they're all bricks. So brick size is equal to h of I minus wall height. And that's how we will continuously calculate the size of bricks when they're added to the wall, to increase the size of the wall. And in the case that since we're increasing our wall height based on the size of this brick, we would push this into our stack. Brick stack dot push brick size. All right, did we get everything that's needed during wall height increase? Yeah, I think so. So this condition is when next point in wall is greater than current point, right? And we'll add another comment here. Iterate through heights of wall. All right, so now we're at our next point, and we have a special condition. So if h of the height is less than the wall height, while wall height is greater than h of I, what we're going to do is pop the brick stack dot pop, and we'll store the brick size that's popped out is equal to, and then we're going to recalculate our wall height, right? So wall height will equal brick size minus, will equal wall height minus brick size. So we recalculated it, and because we did a pop, we're also going to increase our brick counter, right? So those are the three conditions that we specified before. All right, and also remember there's a scenario in which we would have to re-add a brick in the case that the bricks that were removed, our wall height is greater than when the bricks removed and the wall height is actually less than the actual height that's specified at that point, or h of I, we have to get a new brick. right, in order to re-add it. So we'd have a brick size is equal to h of I minus wall height, right? So we get our new brick. If brick size is not equal to 0, what we're going to do is we're going to push it back into the stack. So brick stack dot push and brick size, right? And all right, is there anything else? So at the end of the day, we would return brick counter plus brick stack dot length. Okay, let's see if we got everything. Are there any edge cases? We got a 9. So the question is, why did we get a 9 instead of the number we were supposed to have, right? So we popped our brick if the wall height is greater than h of I, and so while brick counter wall height, and then here brick size, and then we increase our wall height here. Wall height is equal to wall height plus brick size. Okay. All right, we forgot to increase our wall size, so that was a condition. Increase wall size variable. All right, and I think that should be good. So, okay, let's test out our solution. I don't think that this was easy, predominantly because this question could be interpreted in multiple ways. But you will have to get good at these in the case that you want to get a tech job, especially the higher paying tech jobs. All right, let's see how we did. Okay, we made a mistake. So let's go back and try and figure out what we did wrong. Okay, so let's find out why, where we made a mistake. So we'll go back to our lesson, stacks and queues, start. And the mistake was actually posting the old code, the same thing we missed in our first condition. See the wall height, after we push in the brick size, we increment the wall height to compensate for that. Here we created a new brick, we pushed it into the stack, but we didn't increment the wall height. So by adding this section here, and increment wall height. All right, so we did that. That was the step we missed. Submit task. All right, and we got 100%. I don't feel like this was an easy problem, at least not for me, and we completed in O of n time because we have one major loop, right? I didn't think it was that easy, in particular the comprehension, but this is how you grow. You encounter problems you couldn't have thought of how to solve yet, and you learn how to solve them, and then you apply the concepts learned to other problems. All right, until next time. That's Stone Wall from Codility.